Welcome to the 12th standard paper style or 12th standard mathematics. Paper will be of two parts, part 1 or part A or part B. In part A, there will be 50 MCQs, each of 1 mark. So 1 mark into 50, so total there will be 50 marks of part A, which will be having MCQs only. Each MCQ will have 4 options, namely A, B, C, D. Then we have part B. In part B, there are 3 sections. Section A, Section B, Section C. In section A, we'll have 2 marks questions, total 8 questions, so 2 into 8 will be 16. So section A will have 16 marks. Then in section B, we'll have a question of 3 marks. There will be 6 questions, so 3 into 6, 18. So for section B, there will be 18 marks. Then in section C, there will be questions of 4 marks and 4 questions. So total 16 marks. So total of A, B and C will be 50. So 50 marks for part A, 50 marks for part B, total will be 100. This will be the paper style in the 12th standard. Let us begin with chapter 3. Name of the chapter is Materices. Chapter carries 7 marks. In board exam, there will be questions of 7 marks. If you see the word matrices, it is actually plural. It is plural of the word matrix. That matrix is a word and its plural is a matrices. So matrices is plural of matrix. So the word matrices is plural of matrix. Then what is a matrix? Let us see definition of matrix. See the definition. A matrix is an ordered rectangular array. Array means arrangement. So matrix is an ordered rectangular array or arrangement of numbers or functions. Numbers or functions. Rectangular array means, see below. Here we have this type of notation. In the rectangular form, we have numbers 2, 5, 3, 1, minus 4, 8. So this is called a matrix. Generally, matrix is denoted using capital letters. In case of set also, we denote a set by capital letter. Likewise, a matrix is also denoted by capital letters. So if that A is equal to, then this type of braces or brackets, and then numbers in a rectangular form. It can be square also. So again, if you see the definition, a matrix is an ordered rectangular array or arrangement of numbers or functions. In terms of numbers, we can have some functions also. For example, or matrices are denoted by capital letters like A, B, C. So for example, A is equal to matrix 2, 5, 3, 1, minus 4, 8 is a matrix. So this is definition of matrix, that it is a rectangular arrangement of numbers. Rectangular arrangement of numbers is a matrix and denoted by capital letters. Now if we observe the rectangular formation of numbers, then if we see horizontally, then horizontally they are called rows. So 2, 5, 3 is row 1, 1 minus 4, 8 is row 2. So row 1, row 2. If we see vertical arrangement of numbers, then here we have 2, 1. So this is known as first column, if it is vertically. Then 5 minus 4, this forms second column. 3, 8 forms the third column. So if it is horizontally, they are known as rows, row 1, row 2. If it is vertically, we have column 1, column 2, column 3. So in a matrix, we have rows and columns. So the horizontal lines, if you see, the horizontal lines of elements constitute rows, and vertical lines of elements constitute columns. So in short, we have rows and columns. So in matrix A, we have 2 rows and 3 columns. So hence matrix A has 2 rows and 3 columns. Now we know what is row, what is column. Similarly, if we consider matrix B, it is also rectangular arrangement of numbers. So matrix B is equal to, in the first row 3, 8, then minus 2, 4 in the second row, 5 minus in the third row. So this matrix has 3 rows and 2 columns, row 1, row 2, row 3. And then columns, column 1, column 2. So we have 3 rows and 2 columns. Then matrix C, in first row we have sin x, cos x and 1. In second row 1, sin x 0. In third row 0, tan x 1. So we have 1 row, second and third. If it is columns, we have column 1, column 2, column 3. So this matrix C has 3 rows and 3 columns. So again, it is a rectangular arrangement of numbers, and we have rows and columns. We can count how many rows are there, how many columns are there. In general, if we had notation for number of rows and columns, then it is known as order of a matrix. Order of a matrix represents how many rows are there, how many columns are there. So order of a matrix, if you see the definition, a matrix having m rows, small m rows and n columns is called a matrix of order m by n. This we have to read as m by n, not m into n, it is m by n. So order of matrix m by n means it has m rows and n columns. Matrix having m rows and n columns. Then the order of matrix is m by n. If a matrix A is of order m by n, then it can be represented as under. So now we have to see the symbolical notation for m by n matrix, m rows, n columns. So as we have m rows, we have number of rows, row number 1, 2, 3, like that, and last will be mth row. Total there m row. Similarly, if it is column, first column, second column, third, and the last will be nth column. So symbolically, in the first row, element we represent it like this: A11, A12, A13. A11 means element in the first row, first column. Right? It is not 11. We have to pronounce this as 11. A11, element in the first row, first column. Then A12, first row, second column. Then A13, first row, third column. This is first column, this is second column, this is third. So A11, first row, first column. A12, first row, second column. A13, first row, third column. And so on. Total there are n columns. So in the last place, we will have A1n. Right? First row, and it will be nth column, because total there are n columns. So in the first row, A11, A12, A13 is first row, first column, first row, second column, first row, third column, and so on. And last is first row, nth column. Similarly, in the second row, we have to represent like this: A21. So now this is second row and first element. Similarly, second row, second element, second row, third element, and so on. And lastly will be second row and nth element. Or in place of element, we can say columns also: A21, first row, second row, first column. A22, second row, second column, like that. So A21, A22, A23, A2n, these are elements of second row. In third row, similarly, A31, A32, A33, and last will be 3n total. There are n columns, so in the last we'll have n. Now, number of rows 1, 2, 3, and the last we will take m. So in the last row, element will be denoted by am1, mth row, first column, then am2, mth row, second column, am3, mth row, third column, and so on. And last will be amn, mth row and nth column. So will be amn. So this is a symbolic representation of matrix of order m by n. If it is m by n matrix, m rows, n column, then first row, second row, third row, mth row, first column, second column, third, and so on, last be nth column. A11, first row, first element of first column, first row, second, first row, third, first row, nth. In second row, A21, second row, first, then second row, A22, second row, second row, third, like that. And the last AM1, AM2, AM3, AMN. So this is a symbolical representation of matrix of order m by n. It is m rows and n column. There is a short notation also. This matrix in short we can represent by this symbol. Symbolically it is expressed as under, see here, it is A is equal to notation of matrix, and in that we have tried Aij. Aij, I and J are, I is suffix, J is also suffix, then matrix over notation and m by n. See the notation, it is A is equal to matrix Aij and m by n is the order, the m rows and n columns. In Aij, I stand for rows, so there are m rows, so 1 less than equal to I, less than equal to m. Then J is for column, there are n columns, so 1 less than equal to J, less than equal to n, where I and J both belong to n. So we can write in short also Aij, m by n. I stands for row, J stands for column. So if we represent using this type of big matrix, A11, A12, A13 like that, then A11 is the element, the first row, first column, A12 element of first row, second column, and so on. Similarly for AN. Similarly, A21 element in second row, first column, A22 second row, second column, and so on. And in the last AMN, we mth row, nth column. Suppose you consider a matrix A like this. If A is equal to matrix, in the first row 4 minus 2 7. In second row 3 0 minus 5. Then A11 means first row first column, so it is 4. A11 is equal to 4. Then this element second is for notation A12, first row second element or second row, A12 is minus 2. Similarly A13, first row and third element 7. So A11, A12, A13, 4 minus 2, 7. Similarly for second row A21 is equal to 3. A22, second row second element 0. A23, second row third element minus 5. Right, so if we have 2 rows and 3 columns, the elements will be A11, A12, A13, A21, A22, A23. So we can compare and we can write like this. A11 is 4, A12 is minus 2, A13 is 7. Similarly, A21, second row first element is 3, A21 is 3. Then A22, second row second element, it is 0, so it is this element. A23, second row third element, minus 5, so A23 is minus 5. Now, inside matrix we have numbers of functions. Here in this chapter we have to consider only real numbers. We have to see only real numbers. We know about complex numbers also, but in this chapter we will not use complex numbers as elements of a matrix. So in the note First note is, we shall consider only those matrices whose elements are real numbers. Right? The elements are real numbers or functions taking real values. Means no complex number in short. Then second note is regarding total number of elements. If A is an m by n matrix, then total number of elements in A is equal to m into n. If we have m rows and n columns, then total number of elements we can count by simple methods or by common sense. So in this matrix A we have 1, 2, 3, 4, 5, 6, 6 elements, or we have 2 rows and 3 columns. We have 2 rows and 3 columns, so 2 into 3 is 6. So there are 6 elements in this matrix. And in general, if a matrix is of order m by n, then total number of elements in A is m into n, or m multiplied by n. So this way we can count total number of elements in a matrix. Then from these points we can see few questions from exercise 3.1. See exercise 3.1. First question, if the matrix A is equal to, here some numbers are given. In the first row we have elements, 4 elements. In the second row also 4. In third row also we have 4 elements. So matrix A is given. Then write, there are 3 different questions. First is the order of the matrix. We have to write order of the matrix. Order means m by n. M rows and n columns. So if you observe the given matrix, you have your 1, 2 and 3. 3 rows are there. First row, second row, third row. There are 3 rows. And if you see columns, first column, second column, third column and fourth column. So we can observe very easily there are 3 rows and 4 columns. So order of the matrix will be 3 by 4. So if you see answer 1. In answer 1 we have write order of the matrix. So order is 3 by 4. Right? Order of the matrix is 3 by 4. Then second question is the number of elements. So we have to write a number of elements. Actually meaning is total number of elements. In the textbook it is given the number of elements. Actually meaning is total number of elements. We can count total numbers directly, or if we multiply row into column. There are 3 rows and 4 columns. 3 into 4 will be 12. So total there will be 12 elements. So we see the second answer. Second answer, the question is the number of elements, means total number of elements, and answer, total number of elements in the matrix is equal to 3 into 4. 3 rows and 4 columns, and multiplying it is 12. Total there 12 elements. So it is very easy to write a total number of elements in a matrix. 3 into 4 it is 12. Then third question, write the elements A13, A21, A33, A24, A23. We know now in A13 first number is for row, second is for column. So A13 means element in the first row. A13, 1 is for row. So we have to see first row, and 3 means third column. 1, 2, 3. Or in other words, A13 means first row and third element. A13 means first row and third element. Third element is 19. So A13. A13, first row, third element, 19. Then second we have to write A21. Second row, first element, A21, second row, first element is 35. So A21 is 35. Then next is A33. A33 means third row, third element. Third row, third element is minus 5. So A33 is minus 5. Then A24. A24. 24 means second row and fourth element. Second row, fourth element is 12. So A24 is 12. A24, second row, fourth element. Then last is A23. A23, second row, third element. Second row, third element is 5 by 2. A23, second row, third element. Second row, third element. Or second row, third column. That is a junction of second row, third column. Second row, third column. We have 5 by 2. So, as per the notation, we have to locate the element and then we have to write the answer. A13, first row, third element, 19. A21. A21 means second row, first element, 35. A33, third row, third element. Third row, third element, minus 5. Then A24. A24 means second row, fourth element. Second row, fourth element is 12. Then A23. A23, second row, third element. Second row, third element, 5 by 2. So 5 by 2. Then question number 2. See the question. If a matrix has 24 elements, then what are the possible orders it can have? What if it has 13 elements? So there are two types of answers we have to find. The first part, if a matrix has 24 elements, means total number of elements are 24. Now, total number of elements we can obtain by multiplying row into column, 3 into 4 in the previous question, 3 into 4, total 12. Similarly, your product of two numbers should be 24 because total number of elements are 24. So, what can be the order? How many rows, how many columns, that we have to write. What are the possible ways? For 24, we can say it is 8 into 3. 24 is also 6 into 4. So you have to consider all such factors of 24 in how many ways we can get a product 24 rows into columns. So for 24, if we see different factors, see 24 is equal to, we can write 1 into 24. That 1 is also factor, 1 into 24. Or if we change the order, it is 24 into 1. 1 into 24 means 1 row, 24 column. So that type of matrix is also possible. Later on in this chapter we will see we can have this type of matrix also. 1 by 24 means 1 row and 24 columns. Or 24 into 1 means 24 rows and 1 column. We will have this type of matrix also. This is also a type of matrix. So